Bismillah Rahman Rahim. Let start our today's discussion from Lanthanides, occurrence of lanthanides. According to definition, lanthanides are also called rare earth metals, and as I told you, that this definition is not broader definition, and up to some extent, the definition has been made redundant, and this is because of the reason that thulium is as common as arsenic, cadmium, and mercury in earth crust. So these elements are no more rare earth elements because they are not rare in the earth crust as by definition it was explained. Now, what are major sources of lanthanides? So, major source of lanthanide is monazite sand. This is actually uh, a mineral containing lanthanides as a major portion. The color of the mineral is dark, and the composition varies in various parts of the world. So the composition will be somehow different in one country from the other one. And the monazite sand is also available in various parts of the globe or world. Essentially, lanthanides are present in their mineral, which we call as monazite sand, as orthophosphates. Now, these orthophosphates minerals, they sometimes contains up to 30% thorium. A major portion contains lanthanum, cerium, praseodymium, and neodymium. And some D block element like yttrium and other heavy metals, they are also present in the mineral as impurities. Metals containing lanthanides in plus 3 oxidation state, they are poor in europium, and the poor nature, the poor existence of uranium is very clear from its oxidation state because europium is extra stable in its plus 2 oxidation state, while lanthanides, rest of the lanthanides, they are commonly occur in plus 3 oxidation state. So the plus 3 and plus 2, since the families or the nature of the oxidation state do not match, therefore europium cannot be found in minerals of lanthanides in plus, where lanthanides are present in plus 3 oxidation state. The europium, which exists in plus 2 oxidation state in its common compounds, can oftenly be concentrated from calcium group ores where the metals are present in plus 2 oxidation state. So this is the family of europium, where the metal ions contains plus 2 oxidation state. Praseodymium occur in traces in uranium ores, and this is because of the reason that praseodymium is actually a daughter nucleus of uranium, and it is as a result of natural radioactivity in uranium ore, which also is called as fission product of uranium. Milligram quantities of promethium-147 can be isolated using taking advantage of ion exchange chromatography from monazite sand or the ore which has already been concentrated for extraction of these metals. But the promethium is also available in other form, that is actually part of spent fuel in nuclear from nuclear reactors. But this promethium is beta emitter, and it can exist only for 2.64 years, which is half-life of this element. So after 2.64, the concentration of promethium decreases to 50%, and accordingly further decreases as per nuclear chemistry laws or radioactivity laws. So promethium is also available in spent fuel of nuclear reactors. Now coming to extraction of lanthanides, that how they are extracted. So monazite sand, which we already discussed, it contains lanthanides phosphates, and majority of lanthanides which are present in monazite sand are thorium, cerium, neodymium, praseodymium, and lanthanum. Along with some impurities which we already discussed, they can be d block elements or certain heavy metals and we have to separate impurities from lanthanides. The mineral is crushed for the first as a, in the first step, and this crushed mineral is converted into powder. It is digested and concentrated H2SO4. A paste is formed, and this resultant paste is actually sulfates containing phosphoric acid and sulfates of lanthanides, and they contain is phosphoric acid. Now, the paste is centrifuged, and why it is centrifuged? In order to separate solid material from the liquid, because they are present in two different phases, solution phase and solid phase. So solid is centrifuged, solvent is separated from the solid, and then it is treated with cold water. The solution is treated with cold water. So after treatment with cold water, we will get precipitates of silica, and precipitates are actually insoluble. So insoluble silicates can be separated from the solution easily, but with the help of filtration. Now, the solution is then neutralized, and preferably lanthanide oxides, in order to avoid further separation or contamination of the solution. That's why we are using basic oxides of lanthanides: thorium, zirconium, titanium. These three elements, they precipitate out as pyrophosphates, and these pyrophosphates again can be separated with the help of simple filtration. So solid is separated from the other phase, that is solution phase. Sodium sulfate is then added to the mother liquid obtained from this upper step, uh, where lighter lanthanides precipitates out. These lanthanides, they are obtained as solid, and the heavier lanthanides, they remain in solution. So now lighter lanthanides are separated from heavier lanthanides, and precipitates of lighter lanthanides, they are generally double sulfates or double salts of sulfates. They are treated with a hard sodium hydroxide, and their hydrated oxides are obtained comparatively in pure form. Now, we have clearly divided lanthanides which are present in monazite sand into two categories. One category is from lanthanum to samarium, and the other one is beyond samarium to lutetium. So these are lighter lanthanides, and rest are heavier lanthanides. So heavier lanthanides are present in solution form. Lighter lanthanides came in solid form. Solid was again treated with hot sodium hydroxide, and hydrated oxides of these lighter lanthanides are now obtained. Uh, Now these hydrated oxides of lighter lanthanides are washed with plenty of sodium sulfate solution. And why they are washed with sodium sulfate solution? In order to convert hydrated oxides into free hydrated oxides, or simply we can say that water is removed by this use of this sodium sulfate. So then the resultant solid is dried at 100 degrees C in open air, and their dried solid is again processed for separation of other lanthanides. Cerium is completely oxidized, and it is obtained as cerium oxide. Now, approximate composition of the residue at this stage is 50% it contains cerium oxide, 20% it contains neodymium oxide, 17% is lanthanum oxide, 8% is praseodymium oxide, and 5% is samarium oxide. Now, mixture of these oxide is mixed with, or it is treated with dilute HNO3. Lanthanide oxides except cerium, they get dissolved. So only cerium in this mixture in dilute HNO3 is not soluble, while the rest of these oxides are soluble. Now, the system is subjected to, the solution is subjected to filtration in order to separate solid from liquid, and crude cerium, which is not soluble in dilute HNO3, this is obtained, and in solution state we get neodymium oxide, lanthanum, promethium, and samarium oxides. Now, the solid portion or crude cerium oxide, it is now Cerium oxide obtained from this step is crude, so crude must contain certain impurities, and we have to get rid of these impurities in order to get pure cerium oxide, comparatively pure cerium oxide. So this solid is, which was insoluble in dilute nitric acid, is now treated with the concentrated nitric acid, which is 85% pure. A solution is obtained which is acidic in nature, and this solution contains cerium oxide in dissolved form. Excess of H2SO4 is added to this acidified solution, which is already acidic because of this addition of strong nitric acid. And this acidified solution gives this red basic nitrates as precipitates in the solution. Now, since we are getting precipitates, and this precipitate is different phase of solution. So one is the solution phase and the other one is solid phase. So solid can be separated very easily from the solution with the help of filtration. As a result of filtration, we will get solid cerium oxide, and in solution we will get the other respective impurities. So this solid separated in this step then can be subjected to the purification process, and impurities are accordingly processed further. Thank you.